Linear factors. The simplest case in which partial fractions are helpful is when the denominator is the product of distinct linear factors, that is, linear factors that are non-repeating. Keep in mind that for each distinct linear factor in the denominator, you need to add a partial fraction of the following form: the number of distinct linear factors in the denominator of the original expression determines the number of partial fractions.
First example for linear factor. Given the integral of x minus 1 over x squared plus 5x plus 6 dx equals to integral of x minus 1 dx over factor a denominator, which is x plus 2 times quantity of x plus 3. Let x minus 1 over x plus 2 times quantity of x plus 3 equals to the formula for linear factor, which is a over x plus 2 plus b x plus 3. X minus 1, multiply both sides, so we have remaining x minus 1 equals to a times quantity of x plus 3 plus b times quantity of x plus 2. If x is equals to negative 2, therefore substitute negative 2 minus 1 equals to a minus negative 2 plus 3. So negative 3 is equals to a, therefore a is equals to negative 3. Let x equals to negative 3. Substitute negative 3 minus 1 equals to b minus negative 3 plus 2 having the sum of negative 4 equals to negative b, therefore b is equals to 4. Thus, integral of x minus 1 dx over x squared plus 5x plus 6 is equal to negative 3 the integral of dx over x plus 2 plus 4 integral of dx over x plus 3. Then answer is negative 3 normal log x plus 2 plus 4 normal log x plus 3 plus c. Second example for linear factor. Given the integral of 3x squared plus 8x negative 12 over x cubed plus 7x squared plus 12x dx equals integral of 3x squared plus 8x minus 12 dx over factor of denominator, which is x times quantity of x plus 3 times x plus 4. Let 3x squared plus 8x minus 12 over x times quantity of x plus 3 times quantity of x plus 4 equals to a formula for linear factor a over x plus constant b over x plus 3 plus c over x plus 4. Therefore, 3x squared plus 8x minus 12 is equal to a times quantity of x plus 3 times x plus 4 plus bx times quantity of x plus 4 plus c times x plus 3. When x equals to 0, negative 12 equals to 3 times 4 a, therefore a is equal to 1. When x is equal to negative 3, substitute, therefore 3 times negative 3 squared plus 8 times negative 3 minus 12 equals to b times negative 3 times negative 3 plus 4 27 minus 24 minus 12 equals to negative 3b. Simplify, negative 9 equals to negative 3b, therefore b equals to 3. When x is equal to negative 4, substitute 3 times negative 4 squared plus 8 times negative 4 minus 12 equals to c times negative 4 times negative 4 plus 3 48 minus 32 minus 12 is equal to 4c. Simplify again. 4 is equal to 4c. Therefore, c equals to 1. Thus, Integral of 3x squared plus 8x minus 12 over x cubed plus 7x squared plus 12x dx equals to negative integral dx over x plus 3 integral of dx over x plus 3 plus integral of dx over x plus 4. Answer is negative normal log x plus 3 normal log times x plus 3 plus normal log x plus 4 plus c.
Repeated linear factor. One case where you can use partial fractions is with repeated linear factors. These are difficult to work with because each factor requires more than one partial fraction. Remember, for each squared linear factor in the denominator, add 2 partial fractions in the following form. For each quadratic factor in the denominator that raised to the third power, add 3 partial fractions in the following form. Generally speaking, when a linear factor is raised to the nth power, add n partial fractions.
Repeated linear factors, example number 1. Integral dx over x times x plus 2 squared. Using the given formula, let 1 over x times x plus 2 squared is equals to a over x plus b over x plus 2 plus c over x plus 2 squared. Multiply both sides by x times x plus 2 squared. X times x plus 2 squared times 1 over x times x plus 2 squared. Press up. After multiplying, we get 1 is equals to a times x plus 2 squared plus b times x plus 2 plus c times x. If 1 is equal to a times 2 squared is equals to 4a. A is equals to 1/4. If x is equals to negative 2, we get 1 is equals to c times negative 2. C is equals to negative 1/2. If x is equals to 1, we get 1 is equals to 1/4 times 3 raised to 2 plus b times 3 minus 1/2. Then we get 1 and 1/2 is equals to 9 over 4 plus 3b. B is equals to 3/2 minus 9 over 4 over 3 is equal equals to 1/4. Shit. Thus, dx thus integral of dx over x times x plus 2 is equals to 1/4 integral of dx over x minus 1/4 integral dx over x plus 2 minus 1/2 integral dx over x plus 2 squared. One-fourth ln x minus 1/4 ln x plus 2 plus 1/2 x 1/2 x plus 2 raised to negative 1 plus c, and that is our final answer for problem number 1. Problem number 2 for repeated linear factors. Integral x plus 1 times dx over x squared times x minus 1. Let x plus 1 over x squared times x minus 1 is equals to a over x plus b over x squared plus c over x minus 1. X plus 1 is equals to ax times x minus 1 plus b times x minus 1 plus c x squared. If x is equals to 1, 1 plus 1 is equals to a times 1 times 1 minus 1 plus b times 1 minus 1 plus c times 1 squared. C is equals to 2. If x is equals to 0, we get 1 is equals to b times negative 1. b is equals to negative 1. If x is equals to negative 1, we get 0 is equals to a times negative 1 times negative 2 plus b times negative 2 plus 1 squared times c. 0 is equals to a times 2 plus 2 plus 2. A is equals to negative 4 halves or equals to negative 2. Integral x plus 1 dx over x squared times x minus 1 is equals to negative 2 integral dx over x minus 1 integral x minus 2 dx plus 2 integral dx over x minus 1 is equals to negative 2 ln x minus 1 times x raised to negative 1 plus 2 ln x times thus we get x minus 1. Thus we get x raised to negative 1 minus 2 ln x plus 2 ln times x minus 1 plus c. And this is our final answer for problem number.
Quadratic factors. 1. Multiply up. We start by multiplying both sides. 2. Choose values again. We try choose values that make most of the terms vanish. 3. Compare like terms. We can then compare constant terms. 4. Substitute and we now know the values of a, b and c, etc. Note that it's entirely possible for both a repeated linear factor and an unfactorizable quadratic factor to appear in the numerator, and also that in all these cases, the degree of the numerator is less than that of the denominator.
Of x squared minus 1 over x cubed plus x dx. The denominator or this equation should be on its second degree. So let us factor this out. So copy the integration of x squared minus 1 over x times the quantity of x squared plus 1 dx. So we are going to follow x squared minus 1 over x times x squared plus 1 is equal to a over x plus bx plus c over x squared plus 1. Bx plus c because x is on the second degree. So we are going to multiply this by the equation x times x squared plus 1 to cancel this out. All thing to happen is x squared minus 1 is equal to a over x times x squared plus 1 is equal to a times x squared plus 1 plus bx plus c times x, since x squared plus 1 will be cancelled. So x squared minus 1 is equal to a x squared plus a plus bx plus c. So distribute a, bx plus c to x. So x squared minus 1 is equals to a plus b x squared plus cx plus a. So as we can see on the left side of the equation, the coefficient of x squared is 1. So we can determine that a plus b is equals to 1. Cx on the left side of the equation there is no x on the first degree, so we can assume that Cx is equals to 0 and a is negative 1. So since Cx is equals to 0, it means that c is equals to 0. A plus b is equals to 1. Sign a over x plus b x plus c over x squared plus 1 and the integration of negative 1 over x plus 2x over x squared plus 1. So separate the two equation into two different integration. So integration of negative 1 over x plus the integration of 2x over x squared plus 1. Let us assume In this equation, first let us going to write the 2x over x squared plus 1. So u is equal to integrate this equation. So u is equals to x squared plus 1. The du is 2x dx, and du over 2x is equals to dx. So replace 2x over u times du over 2x. So cancel the 2x, 1 over u du. Since 1 over u du is equals to ln u, so u is equals to x squared plus 1. Therefore, the integration of 2x over x squared plus 1 is ln x squared plus 1. Minus the integration of negative 1 over x, as we all know that negative 1 over x, its integration is ln x, and let us add c. ln a minus ln b is equals to ln a over b. So ln else so the whole equation is equals to ln x squared plus 1 over x plus c. Okay, let us go to the next example. Let's proceed to the next example. The integration of 10 over the quantity of x minus 1 times the quantity of x squared plus 9 dx. So let us follow the process of partial fraction decomposition. So x or a over x minus 1 plus bx plus c over x squared plus 9. Just like on the last example. Let us ignore the integral sign and multiply this by the denominator of this equation, which is x minus 1 quantity x squared plus 9. So 10, since this will be cancelled, is equals to a, multiply this, what will remain is x squared plus 9. So a times x squared plus 9 plus bx plus c times x minus 1. Let us substitute x is equals to 1. So 10 is equals to a times 1 squared plus 9 plus b times 1 plus c times 0. So this will be 0. So 10 is equals to a or 10a. So therefore a is equals to 1. So if we don't have any more values to substitute, so let's proceed to the next step. So as distribute the value or the constant a. So 10 is equals to ax squared plus 9a plus bx squared minus bx plus cx minus c. So combine similar terms. 10 is equal to the quantity of a plus b x squared plus the quantity of c minus b x plus 9a minus c. So as you can see on the left side, there is no x squared there and there is no x. Therefore, a plus b is equals to, or it is equal to 0. And c minus b is equal to 0. 9a minus c is equal to 10. As we all know that a is equal to 1, let us solve for c. So 9 times 1 minus c is equal to 10. Therefore, c is equal to negative 1. Since c is equal to negative 1, then b is equal to negative 1, and we all know that a is equal to 1. Since we have the value of a, b, and c, let us substitute it to the given formula or the equation. So the integration of a over x minus 1 dx plus the integration of bx plus c over x squared plus 9. So 1 over x minus 1 dx. Its integration is ln x minus 1. So in this equation, we're going to factor this out. So negative 1 will be outside of the integral sign. It is x plus 1 over x squared plus 9. To integrate this, we're going to separate this into two equations. So negative integration of x dx over x squared plus 9 minus the integration of 1 over x squared plus 9 dx. So let us first integrate this equation. So u is equals to x squared plus 9. Du is equals to 2x dx. Dx is equals to du over 2x. Therefore, x over u, or negative integration of x over u times du over 2x. So cancel the x. What will remain is the 1 over u du. So bring out the 1/2, the negative 1/2, or the negative 1/2 integration ln u. So since u is equals to x squared plus 9, therefore it is equal to 1/2 ln x squared plus 9. So next is the 1 over x squared plus 9. X is, since x it is on the, we are going to use the trigonometric substitution. X is equal to 3 tangent theta, since a squared is equals to 9, then therefore a is equals to 3. X is equals to 3 tangent theta. X squared is equals to 9 tangent squared theta, and dx is, the integration of tangent is secant squared. Therefore, dx is equals to 3 secant squared theta d theta. Next, substitute. The integration of 1 times dx, the value of dx is 3 secant squared theta d theta over x squared 9 tangent theta plus 9. So bring out a factor of 9 on the denominator. So integration of 3 secant squared d theta time over 9 times tangent squared theta plus 9. Tangent squared theta is a trigonometric function. It is the secant squared theta. Therefore, the integration of 3 secant squared theta d theta over 9 secant squared theta. Next, 3 over 9 is reduced to 1 over 3 Let us bring that out. Integration d theta. Since it is equal to 1/3 theta, since x is equals to 3 tangent theta, therefore x over 3 is equals to tangent theta, and arc tangent ng raised to negative 1, x over 3 is equals to theta. Therefore, 1 over this equation is equals to 1 over 3 theta. So it is equal to 1/3 tangent raised to negative 1 times x over 3. Therefore, it is negative 1/3 arctan x over 3. So, combine all the answer. The integration of 10 over x minus 1 times x squared plus 9 is equal to ln x minus 1 minus 1/2 ln x squared plus 9 minus 1/3 arctan x over 3. Thank you very much for listening. Good day.